Hi everyone, and welcome to Pre-Calculus Lesson 4.3, Logarithmic Functions. We're going to talk about what a logarithmic function is, how to do some basic evaluations with them, and some of the properties of logarithms. A logarithm gives the exponent that a base needs to be raised to for any given value. So what happens is you have like log base 2 of 8 equals, and that's saying 2 to what power is 8? Okay, so that would be 3. So the result would be 3 because 2 to the third power is 8. That's what a logarithm does. Now you can change between logarithmic form and exponential form by simply following the pattern. Notice it almost makes like a swirl. So you start at the a here, that's the base. Here's the exponent, so a to the y power equals x. And you can go the other way by simply doing a similar swirl. So log base a of x equals y. Notice the swirl. A to the y power equals x. Log base a of x equals y. Okay, so a logarithm gives the power that a given base is raised to get this number right here. Okay, and you can change between the formats by simply using that, what I call a swirl, if you want to. So let's take a look at an example where we have to change between these two formats. In this example, we need to fill in the missing parts of the chart. So anything in the logarithmic column needs to change into exponential form. Anything in the exponential column needs to be changed into logarithmic form. I suggest pausing this video, trying to do it, and then press play and check your answers. So these are the answers I got. I said 10 to the fifth power equals 100,000. Again, starting here, go around to the end, and then back to the middle number. Okay, so this is my exponential form. Now this one, I'd say log base 2 of 8 equals 3. Log base 2 of 8 equals 3. Now do notice the placement of those base numbers is below the line. It's a subscript. Please make sure to write them below the line because it's not log of 2 to the 8th power. That's different. Okay, so make sure this 2 is below the line. The 8 and the log should be on the same line. Okay, they should be normal text. For this one, I would do 2 to the negative 3 power equals 1/8. 2 to the negative 3 equals 1/8. And for this one, I would do 5 to the r power equals s. Okay, so that's example 1. In example 2, we're going to practice evaluating these. So let's take a look at that. They want you to evaluate each logarithm. So you say 10 to what power is 1,000? 2 to what power is 32? 10 to what power is 0.1? And 16 to what power is 4? So you can do that using a calculator if you want, or you can just try and figure it out. You might know a few of these, but pause the video, try and do it, and then press play. Okay, the powers of 10 can be pretty easy because you just count how many zeros are here, and that's the power. So this is 10 to the third power. The powers of 2, I like to just count up. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that was 5 2's multiplied together, so I get 2 to the fifth power. You could also do it on a calculator and be like, okay, I know 2 to the second power, 2 to the third power. But you might not know the higher powers, and you could just do them on a calculator. For this one, this is interesting because this base is bigger than this that they got from it. So that means that it was either a fractional exponent or a negative exponent. And notice this is 1/10 or 1/10. So that's a negative exponent here. So it's -1. And for part D, 16 to what power is 4? Now I happen to know that the square root of 16 is 4. And you may recall from when we did our exponents in the very first chapter, we talked about how the square root can be written as a 1/2 power. So my power there is 1/2. Okay, so that's example 2. Now we're going to take a look at a few properties of logarithms. Okay, these properties make sense if you think about what exponents do. So remember, this to the 0 power is 1. Anything to the 0 power is 1. So anytime you see a 1 right here, the answer is 0, automatically all the time. Now, something to what power equals itself? Well, anything to the first power is itself. So anytime these two numbers match, you know that this is 1. This one's a little interesting. This is saying a to what power is a to the x? Well, that's to the x power. So these like cancel each other out. So if you see that the a and the a are here, and there's a power on this a, well, that's the answer. And again, this is very similar to that one that we just did. A to the log base a of x. Again, this a and the power of the log a is going to cancel itself out and you just get x. Now, there are a few things we need to talk about as far as some other notation. A common logarithm is going to be a logarithm with a base of 10, but they don't normally write the base as 10. They just leave the base off. So anytime you see a plain log without a number underneath, that means it's base 10. They're looking for powers of 10. There is a special button on your calculator that will do this type of logarithm, and you would just put in whatever number is here where the x was. Okay, now the natural logarithm is a logarithm with a base of e. This is used a lot in scientific applications, and it has special notation. It's written ln, standing for natural log. And the reason that the L and the N are reversed is because this was originally done in another language and it made sense in that language. Okay, so it's ln of whatever number you want. So notice these are just natural logs that echo these. So this is e to what power is 1? Well, that's the 0 power. This is the log base e of e. Well, remember, if the base and this match, well, you just get 1. This is where it canceled out. Log base e of e to the x, well, that's just x. And e to the log base e of x is just x again. Okay, so these are all the properties of logarithms we're going to be looking at in our next example. And this is going to be the last example we're going to do. So let's take a look at it. Okay, these are going to be using the properties of logarithms that we just talked about. So they want you to evaluate each expression. So part A, we have log base 5 of 1. B, you have log base 5 of 5 to the 8th. C is log base 5 of 5. D, 5 to the log base 5 of 12. E is the natural log of e to the 8th. F is natural log of 1 over e squared. I suggest you change that to just a plain exponent. And for part G, you have natural log of 5. Okay, so go ahead, try and do that, and then press play to check your answers. Okay, so 5 to what power is 1? Well, that's the 0 power. That's one of our properties. Remember, these two 5s will cancel each other out, so the answer is 8. 5 to the first power is 5, so that's how that one works. Remember, the 5 and the log base 5 cancel each other out, so the answer is just 12. By the way, all of this is in the exponent. Okay, natural log base e of e to the 8th, so that's saying e to what power is e to the 8th? Well, that's just 8. This is e to the negative 2 power if you make this just a power. So the natural log and the e will cancel each other out. So it's just negative 2. And this I just put in my calculator. There's a natural log button on your calculator. And you just type in natural log 5 and hit enter. And I just rounded to 3 decimal places. Okay. So that's everything for this video. Make sure you write down any questions you have and bring them into class.